Okay, so on problem 9, which of these has a legitimate pair of null and alternative hypotheses? Well, first of all, the null hypothesis has to have an equal sign in it, so we can eliminate options B, C, and D straight away. So HO, P equal to 0.2, and HA, P greater than 0.2. That's good, that works. Let's look down at E and see why it doesn't work. We have P equal to 0.4, that's okay. Well, your alternative has to be the complement of that, and it has a different number here of 0.65. So that leaves us with option A. In number 10, it's Groundhog Day, and we're going to take a random sample of 23, so n is 23, and we want to use data to determine the proportion. So we're doing something with population and sample proportions. 50-50 chance, okay, so that's going to be a sample proportion or a proportion of 0.5, and for both yes and no, so both P and Q are going to be 0.5. Again, our n is 23, and we want to know what the spread of the sampling distribution is. Well, the spread is just the standard error, and the standard error for the sampling distribution of P hat, as we saw just a couple of minutes ago or in the earlier video, is the square root of P hat Q hat over n. So it's just 9 was A, that's on there. Standard error is P hat Q hat over n, and then this just to show you where you might look at on your formula sheet. When I give you the confidence interval formula, which is always the statistic plus or minus Z or T, confidence coefficient, times standard error. So that square root of P hat Q hat over n is the standard error. And then to get the answer, then we will just put 0.5 in for both P and Q, and then 23 for n. And there we have it. The square root of 0.5 times 0.5. Come over here. Say there we have our standard error equal the square root of 0.5 times 0.5 divided by 23. And of course that all comes out to be about 0.104. And 1043, we can go even further. That's option B on number 10. So number 11 is another question on do we have appropriate null and research, do we have a large enough sample to carry out a hypothesis test? And so we're going to want to have yeses and nos both greater than 10 for each one. So in part A there, we'll have 9% of 40. That's about 3.6. That's not going to make it. I've got these all written down here, so I'll go ahead and get to it. So for the next one, 0.1 times 50 is 5, not big enough. 0.1 times 30, not big enough. 0.4 times 100, that's 40, that's big enough, but now we also need, that's the proportion yeses. Let's go ahead and get the proportion nos. That'll be the 100 minus 40, or 60, and that's large enough. So the answer is D, but looking on down to E, and why that's not correct, we have 0.8 times 40, that's 32, that's large enough, but that only leaves, that's 32 yeses, that only leaves 8 nos, and that is not large enough. So again, the answer is D. Okay, so number 12, this is like the one we did just a couple of minutes ago, in fact, with the 90% confidence interval and then what would be the corresponding 95% confidence interval. And so what we're going to do, again, is get the interval width, the distance between the top and bottom of our original interval, half that to get the margin of error, get the statistic by subtracting the margin of error from either the upper or lower limit, and then redoing with the statistic plus or minus old margin of error times ratio of z values. And let me go on here where I've got all of that. So In the red here I have just from minus 0.05, that's the lower limit, up to minus 0.002, that's the upper limit. Then I subtract the upper limit minus 0.02 minus the lower limit to get now my margin of error is 0.048. If I divide that by 2, I'm sorry, that 0.048 was my interval width. Divide that by 2 to get the margin of error. Then take the upper limit, the minus 0.002, subtract the margin of error of 0.024, and that'll give you your p hat, what's in the center of the confidence interval. Move some of this stuff around. So what we're going to end up with here is p hat is equal to minus 0.026, and we have a margin of error of 0.024. So that's what's on either side of the statistic. That's set 4 and in row 5. 0.024 margin of error on either side of the sample proportion. So we have our p hat plus or minus margin of error. That's minus 0.026 plus or minus 0.024. That's our 90% confidence interval. So all I've done so far is take the original interval and break it back down into where the middle, what the margin of error is, half the interval width, and where the middle of the distribution statistic plus or minus margin of error. And now, since that margin of error for a 90% confidence interval was 1.645 times standard error, I can divide by 1.645 here, and that'll give me the standard error, since the 0.024 is z times the standard error. So I'm just dividing the z value of 1.645, and then I'm multiplying by 1.96, which is the z value for a 95% confidence interval. And then I'm just going to multiply all that out, and I get minus 0.045. Minus 0.0545, which is close to minus 0.055 if we rounded that up. 0.0552, and this one rounded up as 0.003, so I carried mine out one more place than they did in the solution manual. And that'll be your answer there, B. Okay, in number 13, we have a hotel chain looking at their reservation processes, and you can either go telephone or online, T or 0. And we have 90 and 68 guests for phone and online, 61 and 44. Since we're just setting hypotheses, I'm going to run through that pretty quickly. We just want to know if we can conclude that the proportion who are satisfied is greater for those who reserve online than for those who do it on the telephone. So first of all, we want the hypotheses. We go over and look at A through E. We can eliminate E and C straight away because the null hypothesis has an inequality in it. And you have to be a little careful on this next part because all of our hypotheses are phone first, then online. And we want to know if online is greater. So if online is greater, phone is less. So I just online greater than phone. I'm just going to go ahead and move that up here, which means online greater than phone, so phone less than online, or T less than O, or PT less than 0 there, and so our answer will be D for number 13. Number 14, looking at a difference between proportions, we get a Z value of 2.99, and let's see here, we're looking at, is it greater than, so we have a one-tailed test and a Z test of a Z score of 2.99. So that's just like any other Z that we've computed before. We're going to that was just our initial thing here. We have our alternative hypothesis is a greater than. Our parameter is PA minus PB. There's no difference. If HO is true, then we'll have a 0 right there. Z is 2.99. So this, all we're saying is we are 2.99 standard deviations or standard errors above 0. And now I take that 2.99, look it up in the Z table. And if you look up 2.99 in the Z table, you will find a value of 0.4986. But the p-value is the area in the tail here, so you'll have to have 0.5 minus 0.4986 to get the p-value. And since this is a one-tailed test, that's it. The p-value is 0.0014. That's B. If this were a two-tailed test, if we just want to know if there was a difference between boys and girls who listen to the music at high volume, then we would have had to have added p-value on the lower end as well, but unneeded in this case. So again, the answer to that one was B, 14B. Okay, so on 15, got a packaging machine here and set to, supposed to put 16 ounces in it. We're going to have a sample size 8, and here are our results. And we want to test the claim that the machine is overfilling the boxes. So apparently this company, they don't care if their customers get too little. They're only concerned about losing money because they're overfilling the boxes. At any rate, that's a one-tailed test as stated here. And so what we're going to do, let's see what I've got on my, okay, good. I just used the calculator. I will go ahead and put here that our HA is going to be mu greater than 16. That's overfilling. So it's a one-tailed upper. And then I'm just going to go to my stat and edit. And I've already done this. I in this case, put all the numbers from this problem, the 16.7, 16, 16.4, and so on, into list 4. Okay, so that's the only thing relevant for this. And you can see I wrote that down over here. I have them, you can put them wherever you want. I put them in list 4. So one sample t-test. If you need to pause, go ahead and do so. I'm going to move ahead, but if you want to follow along with this and try it out, please pause before you and come back after you get the numbers in. Stat, test, t-test, and I am entering data, so that's there. My HO is going to be 16. If we had HA is greater than, then HO, of course, is always going to be the equality for that. My data are in list 4. Don't change the frequency thing. Our HA was greater than, and calculate. And our p-value is 0.0326. It looks like we have a little bit of a rounding issue there, but we'll go with the 0.032. Now let me come back here and say, okay, we're using the 5% level of significance. So we have a p-value of 0.033, really, and we will reject HO because that is lower than the 0.05. So the answer should be C on number 15. On 16, we want to know if we can conclude that the accounting graduates are getting salaries, average salaries, population mean greater than 4907. Of course, HO is equal. We've got that in just about all of them there. And then we want to know if it's greater than, so it's A, mu greater than 49007. Okay, so number 17, we have two different molding machines. So this is an independent samples t-test, or in our calculator, this is going to be a 2-sample t-test. And I should have written on it here, but we're going to use pooled. And I'll try to remember on exam to put that for all of them. If I don't, please just use pooled unless it says otherwise. Or unless you have a computer output that says don't use pooled, like if I had the JASP output or something. So I'm going to now, got my answers at the top of the next page here. Do stat, tests, edit, and I've already, what did I do there? I went too far. Stat, edit, and I have my numbers in lists 5 and 6. You can see I already have those in there. Those are from here. 11, 4, 12, 4, 12, 1, and L5, and then 13, 12, 4, 12, 4. Okay, they're in L5 and L6. And let's see. I want to know if they differ. It says differing here. There's no greater than or implied greater than or implied less than. It's just do they differ. So stat, test, 2-samp t-test, and I have these in list 5 and list 6, not equal to, we'll pool and calculate. And let's see, we want to have our p-value, and that is 0.014, and that's option A.